In this section, we're going to look at concentration time graphs. So concentration is going to be on our y-axis and time on our x. And here we're being asked to draw a graph that represents zero order with respect to A. So zero order with respect to A. Now, concentration on the y-axis here, because that's come first. So concentration of A, units of concentration, moles per decimetre cubed. Time on the x-axis, time in seconds. So how does the concentration of a reactant A change during the reaction if it's zero order? So there's a few thoughts we might have here. We know that concentration of a reactant will start high. So we know our graph's going to start up at the top somewhere and it's going to fall during the reaction. So concentration of A falls during the reaction. So we can write that down. It means it's going to go down. Is it going to go down in a straight line or in a curve? Now, what we also know about concentration time graphs is that the gradient of this graph represents the rate. And the rate of a zero order reaction is the same at all concentrations. So the gradient must be the same at all concentrations if it's zero order. So the rate or the gradient is the same for all concentrations of A. So what that means is this is going to be a straight line starting high and decreasing. I'll just do that again because my hand slipped. And so we've got a straight line down. The steepness will give you an indication of the rate of that reaction, but remember it's not dependent on A. It's the same at all concentrations. Now if our graph is first order with respect to A, so again we're going to plot concentration time graph, so concentration against time, then what we'll see is that the rate will change as the concentration of A decreases. The rate will also decrease. And remember that the rate is the gradient. And it will decrease in the same sort of proportions, but that's quite hard to think about on the graph. What we know is that it's going to start off at high concentrations and be faster, so steeper, and then it's going to curve and it's going to level that off, okay? Now, if you actually did something on this graph called measuring the half-lives, which is where you could halve the concentration of A and measure the time taken, and then repeat that process, half it again and measure the time taken again, what you'd find is that these half-lives were exactly the same all the time. So it was decreasing in the same proportions. If our graph is second order with respect to A, then what we know for a second order reaction is that the concentration has a bigger effect on rate. So our curve is going to be steeper at the start because concentration has a bigger effect on rate. So we'll just write that little note on rate, remembering that rate's the gradient, so it's going to start off steeper. And if we were to measure the half-lives on this one, we would find that they would increase because they would be very short at the beginning and they would get bigger as time went on. So these are our three shapes: zero order, a straight line; first order, a curve with what we would call constant half-life; and second order, a curve with increasing half-life.